In this video, we are going to work on solving inequalities with variables on both sides of the inequality sign. If you look at our example below, you'll notice we have a 4x on the left side of the inequality and a 7x on the right side of the inequality. We have variables on both sides of the inequality, and if we are going to solve them, we need to get all of our variables on one side and all of our constants on the other. Now, this is going to be very similar to solving equations with variables on both sides, where the only difference here is we have an inequality symbol instead of an equal sign. So if I want to have all of my variables on one side, I must first decide what side to move them to. For simplicity's sake, we are going to want to move all of our variables to the left. So I'm going to take my 7x, and I'm going to have to move it over here. In order to do that, I have a positive 7x, so I have to take it away from the right side through subtraction. And if I subtract from the right side, I have to subtract from the left side. So I have 7x minus 7x, which is 0. And I have 4x minus 7x, which is negative 3x. And everything else has stayed the same, so this is greater than or equal to 6. Now this looks like a single step inequality that we worked on in a different video. I need to isolate my variable, and since negative 3 is multiplying by x, we need to divide to undo our multiplication. So I will divide by negative 3. Negative 3 divided by negative 3 is a positive 1, which gives us just an x. 6 divided by negative 3 is a negative 2. And since we divided by a negative, I need to flip my inequality sign. So instead of being greater than or equal to, it changes to less than or equal to. And our solution here is that x must be less than or equal to negative 2. This is how we solve inequalities with variables on both sides. Let's take a look at a couple other examples and see how we can solve them. Here we have a little more complicated inequality that we are going to have to solve. I have 5t plus 1 on the left side, and this is less than negative 2t minus 6 on the right side. Once again, I have variables on the left and on the right, and I need to combine all my variables on one side. Just like before, we want to take all of our variables and move them to the left. So I have a negative 2t. If I want to move it to the other side, I need to do the opposite of its sign. Well, negative 2t means that we are technically subtracting 2t, so the opposite would be addition. I must add 2t to both sides. That gives us 7t plus 1 is less than negative 6. Now we have all of our t's on one side, which is what we wanted, but all of our constants need to be on the other side. That is the only way we're going to be able to solve for t. So I must move my plus 1 to the right side. And since I am adding 1, my inverse operation is subtraction. So I am going to subtract 1 from both sides. Plus 1 minus 1 becomes 0, and we are left with 7t is less than negative 7. Our final step will be to separate the t from its coefficient of 7. We are multiplying 7 times t, so to separate them and isolate our variable, we need to use the inverse operation, and the inverse of multiplication is division. So we will divide both sides by 7. 7 divided by 7 is 1, and we're left with just t. Negative 7 divided by positive 7 is negative 1. And since we divided by a positive 7, our inequality sign stays the same. So we are left with t is less than -1. We are going to do one more example that shows how we can handle variables on both sides, and this final example will deal with the distributive property. For our final example here, we have 4 times the quantity y minus 1 is greater than or equal to 4y plus 2. We have y on the left side of our inequality and y on the right side. So as in with our previous 2 examples, we are going to have to move all of our y's to the same side. But before we think about moving this 4y to the left, we must first distribute. So we're going to have to distribute the 4 to the y and to the -1. That's going to give us 4y minus 4 is greater than or equal to 4y plus 2. Now I can move all of my y's together, and I'm going to subtract 4y from both sides. When I subtract 4y from both sides, though, we should notice 4 minus 4y on the right is 0. 4y minus 4y on the left is also 0. And we're left with -4 is greater than or equal to 2. We have no variable left. And if we look at this, we should notice this is a false statement. -4 is not greater than or equal to positive 2. This is called a contradiction. And if you end up with a contradiction, you have no solutions. So in this example, there is no solution that would work out for us. No matter what we put in for y, it is never going to make the left side greater than or equal to the right side. Now, if these were different, and if, let's say, our answers came out to be 2 is greater than or equal to -4, if these were reversed, well, this is true. And since there's no variables, this would be an example of all real numbers, ARN, all real numbers, meaning no matter what we put in for y, we would always get a true statement. So those are 2, and this is also, not only is it all real numbers, its fancy term is called an identity. So we could have contradictions where in the end we have a false statement, which means we have no solutions, or we could have an identity where we'd get a true statement without any variables, and that means our solution is all real numbers. Alright, that's it for this video. I hope you've had some help with solving inequalities with variables on both sides. Good luck with your practice.